Hello students, in this video we are going to be talking about the process of science. So by the end of this video there are a few things you should be able to do. First of all, you should be able to define science. You should be able to outline and describe the scientific method. You should be able to explain how deductive and inductive reasoning are used by scientists. And then finally, you should be able to describe the components of a well-developed scientific experiment. So what is science? Simply put, science is a way of knowing. So it's making observations, careful measurements, and doing experiments that allow us to gain information about the world. The first two of these, the observations and the measurements, are a type of science known as observational science, while using experiments is a form of science known as hypothesis-driven science. And hypothesis-driven science is what makes science so powerful, because it allows you to make testable predictions. And so we're going to talk a little bit more detail about hypothesis-driven science. But first I want you to understand what inductive and deductive reasoning are, because both of these are used by the scientific method. So inductive reasoning is taking specific observations and generating general conclusions, while deductive reasoning is taking these general conclusions and using them to generate specific predictions. So when you're doing a experiment, you use the inductive reasoning to form a hypothesis, and ultimately you will use deductive reasoning then to test that hypothesis. Example of this would be if you know that mammals are animals that feed their offspring using milk, and you make the observation that a rabbit is a mammal and has fur, a cat is a mammal and has fur, and a dog is a mammal and has fur, you might then come to the conclusion that all mammals have fur. You can then test this by going out into the world, finding a mammal and seeing if that mammal actually has fur, or you could alternatively look and find animals with fur and see if they are mammals. So you're generating testable predictions based on the overall general conclusion that you came to. So let's talk about the scientific method. Take in mind that this is just one way of illustrating the scientific method. There are many different ways that it is illustrated. This is the format that I like and that we will be using in my class. So you start with observations, that's what these eyes down here represent, and questions. I put an arrow in between these because ultimately your observations are going to help you generate your questions, but your questions may lead you to make observations that help you to refine your research questions. So there's a back and forth here that isn't always illustrated when you see the scientific process made in a straight line. The research question then allows you to generate a hypothesis. So a hypothesis is a tentative answer to the research question. The hypothesis leads you to generate predictions. These predictions should be testable, such that you can perform an experiment which, when you get the results of it, will allow you to come to a conclusion about that hypothesis. Now there are two conclusions that you ultimately can come with. So you can find that your hypothesis is supported if your experiment fails to reject your hypothesis. Notice that I am not saying that this proves your hypothesis. Science does not allow you to prove something with absolute certainty. You can just gain more and more confidence in it as you fail to reject your hypothesis over and over again. Alternatively, if your hypothesis is not supported, you would reject the hypothesis. And if this was to happen, then you might come up with an alternative hypothesis or test an alternative hypothesis that you've already came up with and go through this process again. Now, something I want to emphasize here is that a single hypothesis can generate multiple predictions that can be tested by the experiment many times, and that this is a very reiterative process. So as you go through this over and over again, you gain more confidence in your hypothesis being true as you fail to reject the hypothesis over and over again. Now, you'll notice that I delineate hypotheses and predictions. This is not something that is always done by people that teach the scientific method, but I believe that there is a distinction here, and it's an important distinction. So you may have heard that hypotheses should be stated as an if-then statement. This is true if it's a statistical hypothesis. So if you take statistics and you talk about hypotheses in there, they're going to be stated as if-then statements. However, a research hypothesis is not an if-then statement. An if-then statement means that you are having a prediction of some sort. And a hypothesis is not a prediction. It's a tentative explanation for the world. So I like to think of hypotheses as something that are stated in the present tense. This is how it is, while predictions are things that will happen if your hypothesis is true, or are also true if your hypothesis is true. So they're predictions that come from your actual hypothesis. So, as I said, a scientific hypothesis is the tentative answer to the question. So let's go through a hypothetical scenario where you are trying to turn on the TV with the remote, but the TV won't turn on. The obvious question here is, why won't the remote turn on the TV? And you can come up with many different hypotheses about why this won't work. The batteries might be dead in the remote, the TV might be unplugged, you may not have power to the TV, you might be using the wrong remote. All those would be valid hypotheses as long as you used observations to come up with them. And so then your hypothesis, we're going to go with the remote, the batteries in the remote one. So the TV won't turn on because the batteries in the remote are dead is your hypothesis. But a prediction that comes from that hypothesis would be, if the batteries in the TV are dead, then putting in fresh batteries will fix the remote and you will be able to turn on your TV. All right, so let's get into the actual anatomy of an experiment. An experiment is essentially a way of controlling different variables such that you can figure out if one variable has an effect on a different variable. So variables are just potential things that could vary in an experiment. Ideally, you want to make it so that there is only one thing in each group that you are observing that is changing between them. And that thing that you change from group to group is your independent variable. So independent variable will always change in an experiment. It's independent of anything else. That's why it's changing. I am changing the independent variable. Both of those things, I and the word I and independent variable starts with I, because I am changing the independent variable. The dependent variable then is the outcome of that experiment. So will a dependent variable change in an experiment? Well, it depends on whether the independent variable is having an effect on it or not. So the dependent variable is the outcome you measure. The independent variable is the thing that you actually manipulate. Every other variable that could potentially change is a potential confounding variable that you want to make sure that you don't change. If you take a look over here on the graph on the right, you'll notice that on the x-axis going horizontal, we have the year in school, and on the y-axis we have the number of college classes taken. So your x-axis is the independent variable. That's the thing that I'm looking at in between each of these groups, while the y-axis is the outcome that we're measuring. So in this case, I think you would conclude that the independent variable is having an effect on the dependent variable. The longer you've been in school, the more college classes that you would take. Now, many scientific experiments need to take advantage of a control group versus a test group. So a control group is a group which everything stays the same, so you keep everything as it would normally exist, while the test group is when you are having everything identical to the control group except for one variable that you change. And so you are changing this independent variable to see if it has an effect on the actual outcome of the experiment. Now, controls are important in experiments as well. You can have both negative and positive controls. Negative controls are by far the most common, and when we talk about the control group versus the test group, the negative control is what we're typically talking about. So that is a group where you don't change the independent variable, but you do in the experimental group or test group. So negative control has no change in the variable. A positive control, however, will be a group where you actually manipulate the independent variable, but the manipulation that you give it is known to actually have an effect on the dependent variable. So I'm a biochemist by trade. We're going to talk about proteins in this class. An example of negative and positive controls when you are trying to detect proteins in a sample. So you can use a Biuret test to actually see how much protein is in a sample. A negative control group would be a test tube where your sample has everything in it that your test sample has, except it's lacking the protein or other substance that you're having. So if you have some sort of buffer that it's dissolved in, that buffer is going to be in the negative control, but the actual stuff, let's say it's a soil sample, it's not included in that. So it's just has, for example, maybe distilled water in that sample. A positive control would be something that actually has a change. So you might put some sort of milk protein into a positive control because you know that it's going to actually detect the protein of interest. All right, so let's go through an example of the scientific process. So a question that you might have right now is how you can do better on test, and specifically, how can you remember material for the final exam better? So there are a number of observations that you or I may make that are related to this problem. So one observation that I've made and that others have made is that students may spend a lot of time actually studying by rereading their notes in the book, but they might not actually do well on the exam. This is sort of a passive way of studying. Alternatively, students who engage in a more active form of studying by quizzing themselves I have found that they have actually seemed to do better on remembering that material. So using flashcards, for example. So the hypothesis that I generated here is that frequent quizzing of material arrests forgetting of the material that you've been quizzed over. So based on that hypothesis, I might come up with one or more predictions. So one prediction, students that quiz themselves regularly will do better on exams. Or if a student includes frequent low-stake quizzes in his class, then the students in that class will do better on exams that contain that material. Or finally, in the same class, if students were exposed to some material repeatedly via quizzing and other material repeatedly via reading, they're going to do better on the material that was reviewed via quizzing. So here's this last prediction kind of playing out. So on the left here, we have what is a hypothesis and different choices that you can choose for that hypothesis. On the right, we just have an explanation of what a theory is. And so I may expose you to what a hypothesis is and quiz you over it multiple times, while the theory, I just flash that up during class and you read the material, but you don't actually quiz yourself over that material. I then give you a test on it later, and then based on the results of that exam, I found that the topics that we reviewed by quizzing, students did statistically better on that than the topics that were reviewed just by rereading the material. And so this outcome would actually support my hypothesis. Notice I didn't say prove my hypothesis, but it gives support to the idea that the frequent quizzing will result in doing better on the exam compared to just frequently rereading the material over and over again. All right, well, I hope that was helpful, and I will see you guys in class.